Number 12 then of review set 16a. Find modulus an argument of 2z to the power negative 1 if z is cis theta. So 2z to the power negative 1 is 2 cis theta to the power of negative 1, which is 2 to the power negative 1, and then the cis of theta over negative 1, so that's negative theta. 2 to the power negative 1 is a half. Therefore, the modulus is 1/2, and the argument is negative theta. Part B is a bit more tricky. 1 take z, that would be 1 take cis of theta. And since I can't do much more there, what I choose to do is to write cis theta as cosine theta, and also I sine theta, like this. And now what I need to find is, of course, the modulus of that one. So the real part is this, and the imaginary part is negative sine theta. Negative sine theta. So the modulus of 1 take z now is 1 take cosine theta squared, and then plus sine theta squared. I didn't need to do that. And the root of that. So if we expand this further, it's 1 take 2 cosine theta plus cosine squared theta plus sine squared theta with a root. And of course these two here make 1 together. So it's the root of 2 take 2 cosine theta. Now you can work this out further, but I don't think that's necessary really. For the argument, there's a bit of a problem here. You could say the argument is, well, the arctangent of negative sine theta over 1 take cosine theta. But that's a really tricky thing here. What we might want to try to do though is just create, oh, that's an ellipse. Yep, that's a circle. Create a little drawing and see what happens. So our z could be, could be there somewhere. That could be z. And the factor 1 is, of course, that one there. So now we have 1, and that one there is z. So 1 take away z in factor terms is going to be that vector, oops, that did not quite work as I want it. Yep. Is that vector there. So it's 1 and then a negative z on it. So the resulting vector, the vector that we're actually after, is that one there, the black one. Now, if z has an angle of theta there, then due to this one being parallel with that vector there, there is another angle theta right there. Also, the modulus of z is 1, since z is cis theta, so there's a 1 there. And the modulus of 1 is also 1. So this vector here is just as long as our z vector there, which means that this triangle here, the bottom triangle, is an isosceles triangle. So this angle there is the same as that angle there. Now we are after that angle, because it's the angle of the black vector, the resulting vector. So that angle is 2 pi, because in the triangle the angles add up to pi. Take away theta over 2. Yeah. So the argument is pi over 2, take theta over 2, and there you go.